All right, here we go. The natural exponential. So this E is defined as the limit. We haven't really got into the limits yet, but you'll see what they are in the near future. So the limit as n approaches infinity, um, with 1 plus 1 over n, all to the nth power. And what that's saying that so there's n here and here, and that as it gets closer and closer and closer to infinity, um, so this 1 divided by n, that's going to get into a smaller and smaller and smaller fraction. But at the same time, it's being put to a higher and higher and higher power. And what this number ends up being, or right around anyways, is, well, first off, this is e. And e is approximately 2.71828. And again, it keeps on going forever. It's irrational, but it just has some really interesting uses in mathematics. Um, and so the natural exponential function is going to be y equals e to the x power. And later on in calculus, you'll learn kind of this has got a really interesting derivative of it. And how we're going to kind of use it for right now is y is equal to, and just like we've had some of these other exponential functions, some a value times e to the x minus h. And so that x minus h will kind of move our function left or right, and then plus k. So that'll move our function up or down. In particular, we'll use it for, and kind of this is the second box here. This says if you invest P dollars at an annual rate R, expressed as a decimal, and it's compounded continuously, well, that's different for us, then 2 years later, your investment will be worth P times E to the RT power dollars. And really this continuously is the part that's the E is really needed for. So when we've done annually or monthly or whatever it is, we've had to, instead of E, we've had to use the base there would be in a little bit different number. And what E is allowing us to, not just after every month recompounding it or after every day recompounding it, we can get closer and closer to the smaller piece we cut it into. But continuously means that just moment by moment, like not even just partial seconds, just that as soon as a moment passes, now that amount of interest is also being compounded. And so here we go. Here's how we would get that. We would have a of t is equal to a sub naught, so the initial amount, times e to the RT. All right, and we'll kind of put that into practice here in the next few videos. But hope that helps.